kilowatt 4, Tango Oscar Radio.
Tango Oscar Radio, Roger, and what's the name?
Tango Oscar Radio, Roger, and what's the name? The name here is TOR, Tango Oscar Radio, same as the suffix in the call sign.
Roger, TOR, and what radio are you running, sir?
Roger, TOR, and what radio are you running, sir? I am running a 890, TS-890, so you're on your second 890 today.
Yes, sir, and geographically, well, you are in Foreland, is that a Roger for sure?
Geographically, well, you are in Foreland, is that a Roger for sure? Yeah, in the middle of South Carolina.
Alrighty, I've got my Foreland beacon running there on my map, so there we go. And you're running that TS-890, and if you would, sir, give me about 10 or 15 seconds and let me listen to you, your audio, as you tell me about your antenna system, Roger.
To you, your audio, as you tell me about your antenna system, Roger. Okay, Jim, currently I'm running on vertical, and it's right parallel to it. The vertical is a full size or a quarter wave 80 meter vertical with about 4,000 feet of radials underneath it.
Whoa, man, you're serious about that. Roger, Roger. All right, well, let's review a couple of things about your audio situation. First off, I'm hoping that you're running your bandpass at 100 to 2900. Is that a Roger?
To 2900, is that a Roger? Yes, that's correct.
Roger, Roger. Okay, now our setup procedure begins with your compressor engaged at a 3. It's a token amount, but it does exactly what we need for it to do to arrive at a 3 dB dynamic range at the end. Roger?
3 dB dynamic range at the end. Roger? Roger. And the mic gain here is currently at 30, and the mic gain goes from 0 to 100, so I'm about at 30 right now.
Roger. Now, the important thing about the mic gain is how it affects your ALC. So with mic gain in hand, go to your ALC meter, and as you speak fairly rapidly, 100, 100, 100, or 100, 200, 300, however you do it, you want a fast, relatively fast cadence, so you can get that meter up to be able to see what it's doing, and adjust it for mid-scale to 2/3. So ALC meter running mid-scale to 2/3 by way of mic gain adjustment. Roger?
By way of mic gain adjustment, Roger? Okay, gotcha. It is a little bit above that right now, so I'm going down just a little bit here on the mic gain. Mic gain is now at 27, and it's running about half to 3/4 scale here. Go ahead.
Yes, sir. And we do that because we want, I mean, we could get fatter, but what happens if you get above 3 dB dynamic range, the words really start to blur. And you actually start defeating your purpose because those words are becoming noticeably distorted as they get fatter. So we picked a 3 dB dynamic range because it's a nice compromise. It's an 80 to 85% of average peak modulation and just crystal clear words. Roger?
Just crystal clear words, Roger? Roger. And just as FYI, I'm running with the processor on, of course.
Yes, sir. Yeah, we wanted. That's part of the setup procedure. Keep that compressor on at a 3, Roger.
That's your compressor on at a 3, Roger. Right, and the compression is showing about 10 dB at the moment when I'm talking.
Yeah, you have a 1 to 10 input level control on the compressor, 1 to 10, or is it 1 to 100?
Compressor 1 to 10, or is it 1 to 100? Well, it's actually 1 to 100, actually, but the meter itself goes from 0 up to 20 dB, and I'm right at 10 dB right now.
Roger. What would happen if you were to put the input level at a 30 out of 100? In other words, what we normally do is say a 3 out of 10, 30 out of 100. If you were to put that on a 30, and let me listen to you.
30, and let me listen to you. Yeah, okay. Let me see here. Let me get into the menu here real quick.
Because you know the thing is, the way a compressor works, a 30 out of 100, it gives you the same thing as a 60 out of 100 without the suck up. You know, the only thing, when you pass a 3 or 30 and increase the compression, all you're managing to do is just suck up stuff between words. You know, it doesn't help you on the actual word itself. So a 3 out of 10, 30 out of 100 is the ideal setting to help you on the word itself.
On the word itself. Okay, I think we doubled a little bit there, Jim.
Repeat.
Repeat. I think we doubled a little bit there. What I was saying is I got input on the processor. I got an input and an output. The input is currently at 80 out of 100, and the output is currently at 27 out of 100. QSL?
Roger. Take the output at 50. Take the output at 50 and the input at 50, and let's see what we got there. Output at 50 and the input at 50.
Put it 50 and the input at 50. Okay.
I'm sorry. Actually, we want that input at 30.
I'm sorry. Actually, we want that input at 30. Right now, they are both at 50. Input is at 50 and output is at 50. Go ahead.
Roger, TOR. Okay, take that input and put it at 30. I'm sorry, I wasn't thinking straight. It happens as we get on through the hour here. But yeah, input at a 30 and the output at 50.
And the output at 50. Yeah, I can see on the ALC it's way up there, so I'm going down to 30 right now. Now the input is at 30 and the output is still at 50. Go ahead.
Yes, sir. And if there's a discrepancy with your ALC, use your mic gain to control it. Leave your compressor set 30% input, 50% output, and with your mic gain, make your ALC meter run mid-scale to 2/3.
Meter run mid-scale to 2/3. All right. Let me see here. It is actually between half and 2/3 as I speak.
Roger. It's a good idea to leave that ALC meter out. I mean, you got to look at something, so you might as well look at something constructive. Be watching your ALC meter here, say for the next week, and just begin to associate your voice level with your ALC meter. Pretty soon, you'll be like magic. You'll be able to voice control your ALC meter. Roger?
Voice control your ALC meter. Roger? Roger. I think we double a little bit again, but the ALC is currently between half and 2/3 when I speak. The compression level on the instrument is down to about 2 or 3 dB right now, instead of what I had to start with, about 10 dB. QSL.
Yes, so that's exactly where we want to be. That's the whole idea. We want that. We don't want to push that compressor, but we do want about 1/3 of its capability. So we want it in there, but not working really hard. So it's nothing that you'll ever hear on the air per se. Roger, Roger.
Here on the air per se. Roger, Roger. Roger. Yeah, it's at between 3 and 5 dB on the deflection on the meter right now.
Okay, on the compression meter. Roger, Roger. That's beautiful. That's exactly where it should be. And the main thing is that your ALC be running mid-scale to 2/3. That is the important thing, Roger.
That is the important thing, Roger. Right, and it is right now. So that should be good.
Yes, so your EQ looks good now. I mean, you could stand a little bit more on the bottom end. If you would like to go to your EQ page, and let's review that just for a moment.
EQ page, and let's review that just for a moment. Yeah, I got, you're right. Everything below about 900 hertz is below zero quite a bit.
Yeah, so what we want to do there, I have on my logbook page about the 5th or 6th cut, is an example of what happens when somebody goes from QSO to contest with that switch on the bottom of the mic, that low roll switch. It's a graphic example of what happens when somebody flicks that switch and thinks they're going to a QSO EQ from a QSO EQ to a contest EQ just by hitting that low roll switch on the bottom of the mic. What happens is the mic just thins out. You know, it doesn't get aggressive, it just thins out. And, the voice going through the full range of audio is about twice as loud as it is when you roll out that bottom end on the bottom of that roll-off switch on the microphone. So it says a lot about the lower frequencies being just as important as the top frequencies. The thing is, I think, to have a very balanced EQ pattern where you have plenty of top-end content and you're good down to 150 cycles or so, so you have a nice full-range bottom end. That the same EQ you can use for QSO or contest, and it's going to cut, just as well in contest, better than other folks that are rolling off the bottom end. Because if everybody rolled off their bottom end, you're the only one that has a nice bottom end EQ was, they're going to hear you,
EQ was, they're going to hear you, Yeah, okay, I understand. I'm in the equalizer I'm using currently, and 1.6 kilohertz is minus 1 dB, 1.5 kilohertz is minus 2, 1.2 kilohertz is minus 5 dB, and 900 hertz is minus 7, and 600 hertz is minus 14, 300 hertz is minus 16, Qso.
Roger. Okay, Tor, let's look at it this way. EQ is normally, I'd suggest that the EQ be flat through the mid-range, because the whole idea behind an EQ is the top balanced to the mid-range and the bottom balanced to the mid-range. And if you mess with the mid-range, it's so much harder for the top and the bottom to strike a balance. So I suggest that everything from 500 cycles up to 1.5K be flat. And that way it's so much easier for the top and the bottom to strike a balance with the mid-range. So I would suggest everything from 500 cycles, 600 cycles, somewhere in there, up to 1.5, 1.2K be flat, and then we will figure out what we need to do for top imbalanced mid-range and bottom imbalanced mid-range.
Balanced mid-range and bottom imbalanced mid-range. Okay. I'm lifting up everything from 600 hertz up to 1.8, and it's completely flat. 600 hertz is way down to minus 14 dB, and 300 is still 16 dB.
Well, let's just put them all to flat. All through that mid-range, we go to flat. And see what we got there, because that's the whole idea, is to not have holes in your audio. You have a fairly fluid microphone, that is fairly frequency response wise fairly linear. So why would we want to do things in the mid-range that would mess with that fine frequency response range of the linear aspects of the reproduction parts of that microphone, Roger?
Yeah, the reproduction parts of that microphone, Roger? Roger. So everything is flat currently flat from 900 hertz up to 3 kilohertz.
Okay, all right. So what's the bottom end? What's it look like?
What's the bottom end? What's it look like? Well, the bottom, I haven't done anything to. It's still 600 hertz is minus 14 dB, and 300 is minus 16. 0 hertz, or all the way at the bottom, is also minus 16.
All right, once you put all those flat, let's just, we'll start from, what's your bottom control? Is it 60, 50 cycles, 60 cycles, 80 cycles? What is it?
50 cycles, 60 cycles, 80 cycles, what is it? It's 0, 300 cycles, 900, 600 cycles, 900 cycles.
What's your lowest frequency? Lowest bottom frequency?
Lowest bottom frequency. The lowest one says 0, so I assume it's a little bit less than 300 because the next one is 300.
Okay, so is that like an 8-band EQ and they start at 300 cycles?
An 8-band EQ and they start at 300 cycles? It's an 18-band EQ. It's the radio EQ itself, 18-band.
Yes, sir, but they start at 300 cycles on the bottom side?
Yes, sir, but they start at 300 cycles on the bottom side? Well, it starts at 0, whatever that frequency is, I'm not sure, Jim, but the next one, number 2 from the bottom, is 300 hertz, correct.
Okay, so that's a doubling harmonic. So if 300 is the second one, would you say the bottom one is 150 and the one above 300 is 600?
And the one above 300 is 600? Yes, that's correct.
Okay, so let's put them all flat. Get them all flat there, and we'll see what we do here.
We'll see what we do here. All right. It's currently all flat at 0 dB, all the way up, all the way from the bottom up.
Wow, sounds nice. All right, let's just go up to the top there. So we're flat from the bottom all the way up to 1.5K?
Way up to 1.5K? No, we're at on the EQ. I'm flat from the bottom all the way up to 3K.
Okay, what you got at 3K?
Okay, what you got at 3K? At 3K I got +2, and I got +2 to all the rest down to the bottom.
Repeat the last? I got +2 on everything down. It's completely flat, Jim. From 3 kilohertz down to 150 or so, +2 dB. Okay, can you hit 0 dB for being flat as opposed to +2? Can you hit them all at 0 dB?
+2? Can you hit them all at 0 dB? Yeah. It's going to just a second or two.
Yeah, let's do that because that, +2 doesn't sound like much, but what you have is a peaky ridge thing all the way through the band.
A peaky ridge thing all the way through the band. Okay, so now everything is at 0. Everything is level here.
All right, and so the top one is what frequency? 3K?
What frequency? 3K? Yeah, 3K is also level at 0 dB.
Excellent. Okay, let's move that 3K +5, +4 at 3K, Roger?
4, +4 at 3K, Roger? Okay, 3K +4 right now.
All right, give me something. Give me about 15 seconds and tell me what you like best about your radio.
What do you like best about your radio? Well, 3 weeks ago I got out of
hand radio 15 years ago. I sold all the equipment. Take it back up, so that's the brand new radio I decided on using.
Okay, what I want you to do now, Tor, is go to your bottommost frequency and roll it 10 dB. Bottommost frequency, roll it 10 dB, or all the way out, whichever comes first.
Frequency, roll it 10 dB, or all the way out, whichever comes first.
Roll it down 10 dB?
Yes, sir, minus 10 dB, or all the way cut.
Yes, sir, minus 10 dB, or all the way cut.
Okay, we're there. Minus 10 dB.
All right. And let me hear you some more. Give me a little bit more, in about 10 or 15 seconds, about something that you would be looking for in the future, about something that you don't have now on your radio that you would like.
About something that you don't have now on your radio that you would like.
Well, I am waiting on an amplifier I have ordered, and it should be here in roughly 3 or 4 weeks, so that'll be a nice addition to the check.
All right, take that low frequency all the way out. It is all the way out, is that Roger?
All right, take that low frequency all the way out. It is all the way out, is that Roger?
It's a -10 currently, but I'll take it all the way down to -24. It's completely down, Roger.
All right, I wish I had a better signal on you. But, all right, so take the next one, the second one up from the bottom. Take it about halfway, about -5 or so.
Take it about halfway, about -5 or so.
All right, 300 hertz.
Not nice to tune up on an active frequency. Not nice to tune up on an active frequency. So TOR, give me another little bit so I can hear your audio.
Give me another little bit so I can hear your audio.
34 kilowatt for Tango Oscar radio in the middle of South Carolina.
Okay, sounds pretty good. Let's get the top end before Mother Nature pulls the plug on us. I want something about 2.5K, 2.5K plus 3, or 2.5K plus 3, if you have something in that region.
2.5K plus 3, if you have something in that region.
Yeah, I got 3.4. It's currently at plus 3 dB.
Okay, take it to plus 6.
Okay, take it to plus 6.
All right. 2.4 is at 6.
Okay, you wouldn't have any power anywhere around, would you?
Okay, you wouldn't have any power anywhere around, would you?
No, I'm waiting on an amplifier. It's not here yet, Jim.
Yes, sir. Okay. Take the one above that. That's 2. What is the one above that one that we just adjusted?
What is the one above that one that we just adjusted?
We just adjusted 2.4. We're going to 2.7.
Yes, sir. 2.7 plus 3 clicks from where you are. 2.7 plus 3 clicks from where you are. Boost 3 clicks from where you are on 2.7.
From where you are. Boost 3 clicks from where you are on 2.7.
All right. I'm 3 clicks up on 2.7. 1, 2, 3. Kilo 4 tank.
Okay, I'm down to 1 SDR. I'm down to Arlington SDR copy in the mail. You sounded pretty good. I just wanted to get, and the bottom end is sounding nice. I just want to be sure that we have enough top end for balance. So come back and let me hear you again on the subject of your choice, Roger.
On the subject of your choice, Roger.
Holy cow, you're loud. Yeah, the subject of my choice. Well, I'm a native Norwegian Viking imported in 1990. You can probably hear the South Carolina accent here real good. So if people ask me, Tor, where are you from, I always answer with from South Carolina.
Roger. I think with there, Tor, I would love to play with that a little bit more, but I think our conditions are kind of not beneficial to us at the moment. I think they're getting worse. I think you're in a good position at the moment, so we could probably get a little bit closer, but right now I think it does well, and we could get some tape out, Gorilla Tape, and taper down for the moment. And maybe if you could join me next Friday, we could double check it. Maybe we'll have some better conditions, Roger. I'm sure it's beautiful. I got a couple of bursts there down on Arlington, and it sounded really good. Arlington SDR is the only SDR that has a full range bottom end. Arlington SDR is good to 100 cycles, so I could really hear balance on that. If I can't copy you on my my regular antenna, which that circuit's good down to 100 cycles, then Arlington is second best, and so you sound good on Arlington, Roger.
Arlington is second best, and so you sound good on Arlington, Roger. Your help, KC9VKV, kilowatt for Tango Oscar radio in South Carolina. Thanks for the help, Jim.
Roger, Tor, and just out of for knowledge there. I've been copying the mail on Arlington, and you disappeared from Arlington, but you showed up in Georgia. So who can say? Anyway, try to grab a hold of us next Friday afternoon there, and we'll take it up some more. Roger?
Friday afternoon there, and we'll take it up some more. Roger? Sure, no problem, Jim. You have a good one there, 73.
Yes, sir. And you're sounding good in Georgia. Sounding really good in Georgia. That does not have the bottom end that Arlington does, but you sound good on both of those. So, that's what we're looking for, something that does have the bottom end but doesn't sound, bad, that it, somebody's not copying that bottom end. Anyway, 73 TOR, and see you next Friday. This is KC9VKV. Oh, and TOR, if you want to, hear your audio, go to YouTube, do a call letter search KC9VKV, followed by the word logbook. That will take you to this recording. It'll be cut number 1 of 1900. 73, sir. Catch you later. This is KC9VKV, Friday afternoon, Qso-Vlog net. If you have a radio you want to check out, give me a shout.
Qso-Vlog net. If you have a radio you want to check out, give me a shout.